Hello and welcome. A rock thrown horizontally at 2 meters per second from the 5th floor of a building, it takes 2.83 seconds to hit the ground. In fact, this word shouldn't have been there, to hit the ground. When another rock is thrown horizontally at 3 meters per second from 10th floor, at what distance from the building it strikes the ground? We are supposed to take G as 10 meters per second square. So there are two situations. One is a rock is thrown horizontally from the 5th floor. Let's say this is the building and this is the 5th floor of the building. From this 5th floor, the rock is thrown at 2 meters per second horizontally. So it has horizontal velocity, it has no vertical velocity. So it is thrown and it will reach the ground somewhere here. Okay. Now see, it takes 2.83 seconds to reach the ground. So time here is 2.83 seconds for this. And this is the 5th floor. Let's say it is thrown from a height h. This is the height h. Okay. And you are told that now from the 10th floor, let's say 10th floor, and we are saying that this 5th floor is this. So let's say that this is the building and somewhere here is 10th floor. I am taking exactly double, right? So it's implied there. It's not stated, but it's implied that the 5th floor, the 10th floor would be twice as high as 5th floor. That's obvious. And here the stone is thrown. Now it is thrown at a velocity of 3 meters per second. This was 2 meters per second horizontally, right? This is 3 meters per second. And you are asked to find at what distance from the ground, this stone will hit the ground. Okay. One can logically say that if you want to draw how this will, the path of this stone is going to land ahead, because you can imagine this because this is from a height. Okay. So it's going to take longer time to reach the ground and it's thrown horizontally at 3 meters per second. So it's going to fall further away. So let's say it falls somewhere, let's say here, okay, or slightly away from this. Let's say it's here. And we are asked to find out what is this distance d. Now this distance d or this displacement can be easily found, if it could have been found out easily, provided we knew the time for this rock to reach the ground. Okay. So this time, let's say it's t. If we had known this, then because the horizontal velocity which remains constant, right, horizontal velocity of a projectile doesn't change, so the distance would have been 3 into t. So this d would have been 3 into t. But we don't know this t, and that is what we want to find out. Now how will you find it out? Now let's come to the given data. This stone is thrown horizontally at 2 meters per second and reaches the ground in 2.83 seconds, right? So it means you can consider this initial vertical velocity of this stone is 0. Same initial vertical velocity of this stone is also 0, right? So the stone is falling down, it's getting displaced by displacement of h, right? And at the same time it is traveling horizontally. So this stone is traveling horizontally and it reaches the ground. So this displacement horizontally, it takes place in 2.83, while at the same time displacement h downward also takes place between the same time. So we can say that this h can be found out by considering the vertical displacement. So consider the vertical displacement. It's as if stone is thrown in the sense it's just dropped. that means its initial vertical velocity is 0, because this is thrown horizontally, its initial vertical velocity is 0. So its initial vertical velocity is 0, it travels a distance of h, that means this is a downward displacement. So we can use the relationship S is equal to ut plus half at square, and here t is given and S is h, right? S is h, u initial vertical velocity is 0, so 0 into t and plus half, this t is 2.83 actually, 2.83 plus half. A is acceleration, which is 10 meters per second square. 10 into 2 t square is 2.83 square. 2.83 square. Now please note that this is h, which is downward, and g is 10, right? 10, if you consider downward with negative sign, right, then you will get h in negative sign, right, with negative sign. But we can consider downward also as positive, it doesn't matter. So directly you will get h as a positive value. So this is the height of the 5th floor from the ground can be obtained from this equation. Okay, so this is our equation 1. Now consider, we know that this height is 2h because this is thrown from 10th floor. So we can write a similar equation for this, and this is t is our unknown. Let me make it capital T because I have used t here. Let me make it capital T here. So I can write, for this equation we can write 2h is equal to ut plus half at square. Again please note, u is initial vertical velocity. We are considering travel downward. So initial vertical velocity is 0. So this is ut is 0 plus half, a is 10 and t square, right? T, capital T I have deliberately in order to distinguish, right? So you have got this equation. So from this equation, so basically from here, from this you have got h, this is of course goes out, h is equal to 5 into 2.83 square, and this is, you can substitute the value of h here. So we can write this as, basically we can write, combine these two equations. This is 1, this is 2, and you can solve this equation. Basically substitute here, we can say half into 10 t square is equal to, please note what we are doing is this, I am writing here is 2h, right? So this is h, so this is 2h, so this will be 2 into h, h is this, half 10 into 2.83 square. Okay, so here we can see that this is 10 goes out, this is, so 10 goes out, so you get t square is equal to 2 into 2.83 whole square. Now you can find out t from here, and you will see that the t will be nearly 4. It's going to be 4.01001 something. So let's say t is 4 seconds. When t is 4 seconds, okay, t is the time this rock takes to reach the ground, that is 4 seconds. We know that this d, as we have said, horizontal velocity is 3 meters per second, right? And this horizontal velocity doesn't change. The time required for this rock to reach the ground is 4 seconds. So the distance traveled, this d is going to be horizontal velocity, which is unchanged, 3 into this distance, sorry, into the time is 4 seconds, is equal to 12 meters. Okay, but also note that this is your answer. Okay, this is your answer. Now I am going to tell you something where you could make mistake. One could imagine that, one could say that this is h, okay, time is 2.83. So if you are just dropping, or if you are just throwing the rock horizontally from a height which is equal to exactly 2h, then you shouldn't say that the time required for this rock to reach the ground will be exactly 2 into t. That's wrong. Why it is wrong? Please note, time from here it's starting from initial vertical velocity of 0. Here also it's starting from initial vertical velocity of 0 and the stone is dropping. Let's say we consider only rectilinear motion, stone dropping. But even then we cannot say that this stone will reach in time equal to 2 into this. Why? Please note that imagine this stone starts falling from this level at 0 initial vertical velocity. When it comes here, it has already picked up some velocity, right? Because it has traveled h, okay? That means what? It is not starting from 0. This stone is starting from 0 initial vertical velocity, but this is started from here, it's 0, but while it comes here, it has already picked up some vertical velocity. So the time which is required to travel, because it is initial vertical velocity is not 0, it will reach the ground in shorter time. So you should not make that mistake of considering the time for this as 2 into 2.83. Otherwise, this is your answer. Answer is 12 meters. Thank you.